Hi guys, it's Dan Perez out of Myrtle Beach. This is a follow-up video to one I put up the other day. Just the other day was the first time I ever ran this motor with my homebrew controller. And there were some things that I realized I had to address. One of the things that was kind of alarming was me running the controller day before yesterday and it kind of running away from me. I did something stupid and I got that controller to ramp up pretty high. I was monitoring the current flowing out of the battery into the controller, and it was high. I probably shouldn't have been doing that with the small gauge wire I have on there. One of the reasons I didn't stop it in time is because on the terminal program I had it set up incorrectly. Well, actually it worked, but the output of commands did not have a carriage return after each command. So the commands would sort of stack on top of each other, and after a while the screen would just become unreadable. So I decided to fix that then immediately after I ran into that little scenario with the controller ramping up my motor to a really high speed. So this program that I use, Putty, I like this program. It's free, it's open source. I invite you to download it. It's been around for a really long time, and one of the features of this program that I barely take advantage of is the fact that you can save profiles for any particular device that you're trying to attach to. In this case, I set up a profile called inverter, and I'm going to load that profile. And of course, I got the baud rate, and there's a tab down here where you can set up the stop bits and all that stuff. But the one thing that I failed to do was go into this terminal tab and check these two items right here. One says implicit carriage return in every line feed, and the other one says implicit line feed in every carriage return. Now sometimes when you're communicating with serial devices, they automatically provide carriage returns. This program is assuming that the device you're connected to is going to provide carriage returns. I guess it's not. So now that I have that parameter set, if I were to type something like, well, actually I typed that wrong. If I were to type get version, you can see the results of that query are now on its own line, and the cursor has been placed at a position where it's easy to see what I'm typing. So if I were to type stop, I wouldn't have to worry about what I was seeing. So yeah, if you're going to use Putty, highly recommend it, but just make sure it's set up right and create a God, what is it? I'm tongue-tied now. Just create a profile for the device and make your life a lot easier. I'm going to show you guys something I bought at Walmart the day before yesterday. I don't want you guys to laugh because I know this is not what I'm supposed to be using in this application. However, this is what I was using before. These things are worthless. They're only good for car radios or CBs or something like that. I think a 10 amp or 15 amp fuse could fit in there. This thing is a fuse block for an amplifier. Now I'm putting this in this video, but I don't condone anybody using something like this. This is made for a car amplifier. It's not made for a high current motor controller. However, I'm only using this on a test bench. It'll never be in a transportation system. It'll never leave this room, nor will this thin wire that I'm using on here. So I monitor it, I sit in front of it, I never walk away from it. When I do walk away from it, I make sure that all the fuses are out and there's nothing could really go wrong. This thing cost me $9. It came with two fuses. It came with a 40 amp and 80 amp fuse. and it was way better than me using these other small things that I was blowing every 5 minutes. That thing right there, I have had no problems with it. It didn't get too warm. The wire got warm before the block got warm, and the fuse never let out. Like I said, I don't condone the use of it. I mean, if you're using it for testing, that's fine. You know, even if I'll use this on another project for something else when I'm done with it here, so it's $9 well spent. And a fuse is better than no fuse at all, right? But now that we're talking about fuses, I'd like to walk around to the other side of the controller and point out something that I thought was kind of incredible. So I'm just going to put this here like this. Walk around. I got a mess in here, but you know, this is my workspace, so if it's not messy, then you're not making any progress. So these are the wires that I'm using on the motor controller. You know, like I said, these are wires I got for free. But I'd like to point out, and all three of these wires kind of look the same now, but if you take a close look at this wire, and you can see on the very bottom edge there what looks like I guess a little wing forming on the insulation. Well, that wasn't there before. That, my friends, is a result of excessive heat. And why was there excessive heat? Well, of course, there was excessive current. And why was there excessive current? Well, you know, I was doing something silly with the motor controller, and while I didn't damage anything, there was a short period of time where this motor was spinning around at a pretty high rate of speed with a lot of current flowing through these wires, and they got kind of warm and toasty. Yeah, way warmer than I would have felt comfortable with. So I'm just pointing this out so that anybody else who has any wild fantasies about doing this has to know that if you're going to experiment in your house and use, you know, wires that's not rated for the application, you have to be sitting right there at all times. You can never walk away from it, because those that truly don't respect low voltage will find out the hard way that low voltage, while it can't shock you, is very dangerous, because it can quickly start a fire. So you know, when I'm not in this room, there's nothing connected. I don't leave the inverter in a state where it could possibly run on its own or run away uncontrolled. But you know, that led me to discover something else that was pretty neat, and I was kind of just awed by the fact that these three wires were spaced just like this. They were equidistant yesterday, and as I was ramping the motor up and down, I observed the wires doing this. It was incredible to watch. They were actually repelling each other just by the amount of current that was flowing through them. And so that led me to believe that, wow, you know, if these wires are just sitting there unwound, sitting next to each other, just imagine the kind of forces that are happening inside a motor with thinner conductors and wound repeatedly around an iron core. There has to be some tremendous forces going on in there. You know, not that any of that information is useful, but I just thought it was kind of cool. I had never seen anything like that. Go back around to the other side here. I wanted to show you guys this motor that a friend of mine gave me. This is made by a company called Jingway Technology, model DP400. This is a little pump. It's not fully submersible. It has these nice little fittings on it. It's rated for 24 volts, but I actually have it connected to a 12-volt bench power supply. And I'm going to use a pump like this to pump either water or glycol through my chill plate. I'd like to show you it run. I have a little bucket of water here I'm going to put on my lap. And I'm going to put this pump in there. And I wouldn't do this with a 120 volt pump in water, but I'll certainly do it with a 12 volt pump. But I gotta make sure I got the arrow in the right direction here. Okay, so once the pump gets primed, it's pushing a good amount of fluid through there. I mean, I think that volume of fluid would more than satisfy the heat exchange in my chill plate. I don't know what head pressure this thing builds or how high it can push water up a vertical column, but I think this is a good starting point, something good for testing. Mind you, I'm running this thing at half of its rated voltage, so I gotta imagine that if I put 24 volts to this thing, it'd probably push a lot more fluid through faster than this. But the thing is, you know, I really don't need glycol or water flying through the chill plate. You know, it just sort of has to coast through there, get excited from the heat of the surrounding metal, and then exit gracefully. It doesn't have to jet through there. So I think this would be more than suffice. I'll let you know as I test. But these things look fairly inexpensive. Looks can be deceiving, but you may want to take a look at it. Jingway Technology, DP400. Put this down. Alright, and so the last thing we'll talk about is I've had a bunch of folks ask me about putting up pictures of waveforms. Now I'm gonna preface this by stating that I am by no means an electrical engineer. I don't have classical training in high voltage electric works. I've never done any work with high current IGBTs. My specialty lies in, you know, low voltage things like embedded controllers, small electronics, amplifiers, things of that nature. This is a new endeavor to me, and while I want to learn everything I can about it, I mean, you can't possibly learn everything overnight. You have to make some mistakes along the way, and I hope to glom as much information as I can from you guys. So this is why I'm posting the video. If you see anything that's unusual or could potentially be bad for the controller or the health of the motor, you know, I invite your input. So with that said, I'd also like to point out that if I were to take my probes and put them on the input side of the IGBTs, I'd get this real pretty square waveform. However, if I were to move those probes to the output side of the IGBTs, those waveforms don't look anything near like what they do on the input side. There's a lot of things going on there that I don't truly understand. There's a lot of noise, there's a lot of transient activity. I assume there's back EMF going on, things of that nature. Things that are really way above my pay grade. But I hope to learn about them as we move along. So what I'll do is I'll come down here and I will start the inverter. I'll just do start 2. Okay. Now, if we look at the scope, you can see a nice square waveform. Now, the only reason that looks the way it does right now is because there's no current moving through the motor. Can't really explain why I can still see this waveform. I'm thinking that maybe only half of the IGBT is being fired, or it may have something to do with the way the phasing between the three outputs are being processed right now. However, if I were to go to the terminal program and modify a parameter called F slip. I believe that changes, duty cycles and phasing in between the three terminals of the motor, and then work is produced. And then when that work is produced, you get to see all the artifacts of that work. So I'm going to come down to the terminal here, and I'm going to do set F slips P and T, and I'm going to set that to some low value like 20. Now if you listen closely, you can hear the motor whining, and if you look at the scope, well, the motor's whining and it's actually spinning. It's not spinning at a high rate of speed, but it is spinning. But this is what I see on my scope. So I'll try to get in as close as I can so you can see the parameters that are set up on the scope. But like I told you earlier, I really don't know what to look for. I don't know what would be considered bad information on this waveform. So if any of you have any input, see something that's potentially wrong, see something that's unusual, I certainly invite you to help me, and maybe we can both help each other at some point. All right, I think I rambled on long enough. I'll put up more videos as I make more progress, but until then, see you around. Bye.